this episode, we focus on wired and wireless network security design, with special attention to a problem that quietly breaks otherwise good architectures: hidden trust paths. A hidden trust path is an unexpected route through which someone or something gains access to systems or data without going through the controls you thought were protecting them. Beginners often picture networks as simple lines connecting computers, but real networks are full of shortcuts, shared services, temporary connections, and legacy decisions that can create invisible bridges between areas that should be separate. Wired and wireless networks also differ in important ways, because wireless extends the network into physical space where signals can be received beyond walls, while wired access usually requires physical presence at a port. The goal is to learn how to design security for both types of connectivity in a way that makes trust boundaries explicit, reduces unnecessary exposure, and prevents accidental bypasses. When network security is designed well, it supports application security and identity controls instead of undermining them with unexpected access routes. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A strong foundation is understanding what trust means in a network context, because network design is largely about deciding what should be allowed to talk to what. Trust is not a feeling. It is a rule that says traffic from a source is allowed to reach a destination and perform actions that matter. If a device can reach a database, that is a trust relationship, whether or not anyone wrote it down. If a guest wireless network can reach internal printers, that is trust, even if it seems harmless. Many hidden trust paths happen when trust is granted implicitly through shared infrastructure, like a shared switch, shared routing, or shared services such as name resolution and time synchronization. Another source is when teams treat a network segment as internal and therefore safe, then allow too many kinds of devices into that segment. An architect's job is to define trust boundaries and then ensure the network design enforces them consistently. If you cannot explain the trust assumptions of your network, you are likely to have hidden paths. Wired network security starts with the physical reality that wired access is often controlled by building access and port availability, but it still needs deliberate design because plugging into a port can be a powerful entry. A common fragile assumption is that any device on an internal wired network is trustworthy, which can lead to overly open access between systems. Wired security design uses segmentation, meaning dividing the network into zones with rules between them, so that compromise in one zone does not automatically grant access to everything. It also uses port-level controls, such as limiting what kind of device can connect and monitoring for unusual connections. Even without discussing specific tools, the key idea is that a port should not be a universal key to the kingdom. When you design wired networks, you define what kinds of devices belong in each zone, what services they should reach, and what traffic should be blocked by default. Default deny thinking is the antidote to accidental openness. Wireless security adds complexity because the network is accessible through radio waves, and the boundary is not the edge of a building but the reach of the signal. Wireless networks therefore need strong authentication and encryption to ensure that only authorized users and devices can connect, and that traffic cannot be easily intercepted or altered. A fragile wireless design often comes from shared passwords, because shared secrets make it hard to revoke access for one person and hard to attribute actions to individuals. Another fragile pattern is allowing wireless networks to bridge directly into sensitive internal segments, effectively making the air interface an entry into critical systems. Wireless also brings the risk of rogue access points, where unauthorized devices create a fake or unapproved wireless network that tricks users or connects into internal infrastructure. Architects address this by defining approved wireless patterns, separating guest access from internal access, and monitoring for unexpected wireless behavior. The goal is to treat wireless as a first-class entry path, not as a convenience network that inherits internal trust. Hidden trust paths often appear at the intersection of wired and wireless, especially when the same infrastructure supports both, but policies are not aligned. For example, An organization might have a guest wireless network that is supposed to be isolated, but it uses shared network services that inadvertently provide reachability to internal systems. Another example is when a wireless access point is connected to a switch port that is configured for a more trusted network than intended, so anyone who connects wirelessly inherits broader access. Sometimes wireless traffic is tunneled through internal networks for convenience, and the tunnel endpoint becomes a bridge between zones. These problems are not dramatic exploits. They are simple connectivity mistakes that create real security risk. Architects prevent them by documenting trust boundaries, validating connectivity paths, and ensuring that configuration patterns are consistent across all access technologies. If a zone is supposed to be isolated, every path into that zone must be accounted for, including wireless bridges and shared infrastructure. Segmentation is one of the most important design tools for preventing hidden trust paths, but segmentation must be meaningful, not just cosmetic. Meaningful segmentation separates systems with different sensitivity levels or different risk profiles, like separating user devices from server networks, separating production systems from development systems, and separating management functions from general access. It also separates untrusted or less trusted devices, such as guest devices, personal devices, and specialized equipment that cannot be updated frequently. A common misconception is that creating many segments automatically increases security, but too many segments without clear purpose can create complexity that leads to misconfigurations, which become hidden trust paths. The better approach is to create a small number of clear zones with well-defined rules, then refine as needed based on risk and operational reality. The key is to ensure that traffic between zones is intentional and controlled, not accidental. Routing and switching design choices can create hidden trust paths if they allow traffic to move between segments without passing through policy enforcement. For instance, if segmentation is implemented in a way that still permits broad east-west traffic, meaning traffic between systems at the same general level, an attacker who compromises one system can move laterally. Another issue is when networks rely on implicit trust in shared routing or shared infrastructure services, like assuming that if a packet is routed internally, it must be safe. Architects often require that sensitive zone boundaries have explicit controls, including inspection and logging, and that routes are designed to force traffic through those control points. Hidden paths also appear when there are multiple ways to reach the same destination, such as backup links, temporary connections, or remote access paths that were added for convenience. If one path has strong controls and another path is weak, attackers and mistakes will find the weak path. A secure network design makes the allowed paths explicit and limits alternatives unless they are equally protected. Network services that everyone depends on, sometimes called control plane services, can also create hidden trust paths because they are widely reachable by design. Services like name resolution and time synchronization are needed across many segments, but if they are exposed too broadly or trust responses too easily, they can be abused to redirect traffic or weaken authentication. For example, if a device trusts a name resolution answer from an untrusted segment, it might be directed to a malicious server without realizing it. If time is incorrect, authentication systems that rely on time-based checks can fail in confusing ways, leading teams to loosen security to get things working. Architects design these shared services carefully, placing them in appropriate zones, restricting who can query and who can respond, and ensuring devices trust only approved sources. They also monitor these services because attacks against them can affect many systems at once. The point is that shared services should be treated as critical infrastructure, not as background utilities. Wireless introduces additional trust path concerns around how devices roam, how networks are named, and how users choose networks. If users are trained to connect to a familiar network name, attackers can create a fake network with the same name in a nearby area to capture credentials or traffic, which is a form of deception rather than direct hacking. A secure design reduces reliance on user judgment and uses strong mutual authentication methods where the device can verify the network as well as the network verifying the device. Another concern is that wireless networks often span large areas, and access points may cover spaces beyond the intended boundary, such as parking lots or adjacent buildings. Architects address this by considering radio coverage as part of the security boundary and designing access policies accordingly. They also design for separate wireless profiles, such as guest, employee, and specialized device networks, each with different trust and reachability. The goal is to make wireless access deliberate and compartmentalized, not a broad doorway into internal resources. Remote access and bridging technologies can create hidden trust paths when they connect external networks to internal segments without the same controls used internally. If remote users connect in a way that places their device directly into a trusted internal zone, you have effectively extended the internal network to wherever that device happens to be. That can be risky because the remote environment may be less controlled, and the device might be shared, compromised, or poorly managed. Architects instead aim to give remote users only the access they need, often through controlled gateways and strong identity checks, and they limit what remote connections can reach by default. They also separate remote access traffic from management access traffic, because management functions have a higher impact and require stronger controls. Even though remote access is not the main focus of this episode title, it is an important example of how hidden trust paths appear. The common thread is that any connection that bypasses standard boundary controls should be treated as a design red flag. Monitoring and validation are critical because hidden trust paths are often discovered only when someone tests the network like an attacker or when an incident occurs. A good network security design includes continuous visibility into what connects, where it connects, and what traffic patterns look abnormal. It also includes periodic validation, which means checking that segmentation rules still match the architecture intent and that new systems have not created unexpected bridges. Validation can be as simple as verifying that guest networks cannot reach internal systems, that wireless device networks cannot reach management interfaces, and that only approved paths exist between zones. Logging is part of this because network events can reveal scanning, repeated access attempts, or unusual flows that suggest misconfiguration or intrusion. Architects also consider how monitoring systems themselves are protected, because if monitoring can be disabled easily, it becomes unreliable. The point is that design is not finished when the network is built. It must be maintained and checked as it evolves. When you step back, designing wired and wireless network security without creating hidden trust paths means making trust boundaries explicit, keeping zones simple and purposeful, and ensuring every path between zones is intentional and equally protected. Wired networks need segmentation and controlled port access, so internal connectivity is not automatically trusted. Wireless networks need strong authentication, encryption, and careful separation so the air interface does not become an unguarded bridge into sensitive resources. Shared services and management networks require special care because they are naturally broad in reach and high in impact. Hidden trust paths are avoided by forcing traffic through known control points, limiting alternate routes, and validating that the architecture you intended is the one you actually have. If you can draw your network zones, explain who belongs in each zone, and describe the few approved paths between them, you have a design that is easier to secure and harder to bypass. That clarity is what turns network security from a collection of rules into a resilient architecture.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.